In question number 13, we're trying to help Jonathan solve this equation here by completing the final step. So let's make sure we understand what each of these first three steps, what happened in each one. So on the first one, well, between first and second, they multiplied by 10, so that gets rid of the 10, and that's how 24 becomes 240. Then they got rid of the minus 3 by doing the opposite, which is adding 3 to both sides. That's how they get 243 here, and the 3 cancels. And then remember that here, they got rid of the fraction power, and the way to get rid of a fraction power is that you flip over the fraction so that they cancel. So we're going to raise both sides to the power of 2 over 5. So instead of 5 over 2, you flip it, and it becomes 2 over 5. So we do it like this. So the x gets a 2 over 5, which is going to cancel, and the 243 gets a 2 over 5. Now, if you remember this similar question from the first packet, this is my answer, and that will be the end of that case. But we don't see this in our answer choices, so we got to do a little bit more work. And it's only just one extra small step here. Keep in mind that this one here, recall that this is called rational form. When you have a fraction in the exponent, it's called rational form. And when you have the radical box, we call this radical form. It's not always a square root box, it's a radical box depending on whatever number is here. Well, the way to change this from the fraction powers, for the fraction powers, you're going to take the bottom number of the fraction and it's going to go with the radical box. So that 5 is going to be right here as part of the radical box. And the top of the fraction, the 2, can either go outside the radical box or it could even go here attached on the 243. But just the most important one is that the 5 has to be embedded in the radical box right here, wedged in there. So the correct answer is A. Question number 14 is the exact same question in the first packet. So what I would like for you to do is not go back to the first packet and find the answer, but instead try to do it on your own based on just what you have here on the question. And also when you find out which equation is correct, type it in the calculator and see if you can figure out how many quarters Horatio has. Whatever numbers your calculator gives you represents the number of nickels, dimes, and quarters. So if you add it up like actual money and it's not 725, then you would know that you made a mistake, in which case you can go back and try to figure out what other set of equations might be the correct one. And on a test, that might be a way that you're able to actually find the answer, even if you couldn't immediately come up with the equations from the beginning, by kind of just trying to do some trial and error and fixing it and making sense of the answers that you get to see if it actually adds up to the total amount. Question number 15, we have inequalities. So we know we're going to be graphing and we see a bunch of graphs. Okay, I'm going to tell you right away that the answer is not going to be A, just because I want the space here so that you can see the other answer choices here. So let's watch the video and we're typing these in like we did before. Okay, we delete the equal sign in order to find, we're going to go straight to the relation because we want to type in the letter X. We want to put X greater than or equal to, remember that control equals is where you find those symbols. So greater than or equal to 0. And it shades only the right side, okay, which is actually going to be important in a little bit. Then we type the next equation, y greater than or equal to 0.2x. So right now our answer is that shaded region on the top right, only that region right now, nothing on the left, nothing on the bottom. And then we graph our third equation, y less than 2/3 x plus 2. And we see that now it created another region that's shaded. So now we have this wedge on the top right, only part of it. Okay, that is our answer so far. And we got one last equation, which we'll type in as negative 2y greater than 3x minus 16. And that's the purple one, which takes that wedge and it makes it into a very smaller piece here. And now I'm moving these equations for a reason. I need to check to make sure which lines are solid. That's a solid line. That's a broken dash line. And the other one is also a broken dash line. And that's going to play an important role right now in deciding which one our answers are. So I'm going to cross off, before I cross this off, remember that the first equation was x is greater than or equal to 0, which shades the right side, which tells me that nothing on these answer choices can be on the left side. So if anything, instead of crossing off C right now, I should cross off D because it has part of the answer on the left side of the x greater than or equal to 0. Additionally, you saw that this line here is bold, it's solid, okay? But the ones that crossed it over here, which you're going to see again in a second, those were not solid lines. Those were broken dashed lines. And that's not the case on answer choice C. Okay, these are solid when they should be dashed. And you'll see it again as the video replays and gets to it. Or you can just rewind. So I'm going to say that the answer is not going to be C because the lines are not the same ones. One is dashed and the other is solid. And it shows it again right here. Solid versus dashed has the wrong ones. And it's also not D because from the very beginning, x greater than or equal to 0 means the right side. So anything shaded on the left side is immediately wrong. So the correct answer here, whoop, I need to mark it. The correct answer here is B. Okay, so hopefully without me even marking it, you'll remember that. Just hopefully you're actually listening. Okay, the correct answer is B.